Hi everyone, my name is Amitesh, and in this video we're going to do a masterclass on this exercise on the tangent line involving differentiation of a function. And this is, as I've taught multiple times at Princeton University, lots of problems have appeared like this, basically the same problem with just the function different. And once you've mastered this, you've really got a strong grasp on tangent lines, how to find tangent lines, and also a tricky exercise at the end. Okay, so let's kind of go through what we're going to do. We've got our function f of x equals x squared plus 2x plus 9. We're going to first find the derivative of f. Then we're going to find the equation of the tangent line at a point, which is going to be x equals 1. Then we're going to find all the points so that the tangent line to the graph passes through the origin. So I'm going to explain that. That's going to be a tricky little exercise, but it's super cool. So let's just dive right into it. Okay, so the first two parts are kind of a warm-up for the third part, but are important to master tangent lines. So let's go for part A first. So what is the derivative of f going to be if f of x is x squared plus 2x plus 9? So f of x equals to x squared plus 2x plus 9. What we do is we just differentiate term by term and use the power rule. So what I like to do is just differentiate step by step. So first of all, we say that x squared, the derivative is 2x. So we're going to just get 2x here. The exponent comes out front and reduces by 1. Okay, so the 2 comes out front and then we get x power 1 plus 2. So derivative of x is just x power 1. So 1 comes out on front, which just keep multiplying by 1 does nothing, and then the exponent is going to be 0, x power 0 is 1, and then the constant, derivative of a constant is always 0 because it doesn't change. So we've got 2x plus 2, so that's going to be f prime of x. That is part A. Okay, nothing more to that. Okay, that's just 2x plus 2. Now part B is going to be find the equation of the tangent line at x equals 1. Okay, so what we're going to do to find the tangent line, this is a crucial problem in calculus. Okay, so I just want to walk you through the steps very clearly. So how do we find the tangent line at a point x equals to 1? Okay, so there are two pieces of data for finding the equation of a line. Okay, so first we need to master the equation of a line. But once you've done that, you need to understand the following two steps. So step 1 is that find the slope. Okay, find the slope of the line. The slope of the tangent line is by definition the derivative. That is literally just the slope of the tangent line. It is the rate of change of the function at x equals to 1. So the slope is just going to be f prime of 1. Okay, and find a point that the line passes through. This is the point slope form. Okay, so of a line. So then we're going to use the point slope form equation of a line to find the equation of the line. But to find a point the line passes through, well, being tangent at a point means it passes through the point. Okay, so if you have a graph, whatever the graph may be, the graph is something like this. Let's say this is 1. Then the tangent line is some line. Its slope is going to be f prime of 1, and it passes through the point 1 comma f of 1. Okay, by definition of being tangent at the point. So we know that find a point it passes through, well, it's going to be just 1 comma f of 1. Okay, so the line passes through 1 comma f of 1 because we're finding the tangent line at x equals to 1. So 1 comma f of 1 is a point on the line. Okay, this is a point on the line. And now that we know that this is a point on the line, what we can do is we can use the slope intercept form of a line. Okay, so, or the point slope form of a line. Okay, so let's do the point slope form of the line. So the equation is going to be y minus f of 1 is equal to f prime of 1 times x minus 1. That's going to be the equation of a line. Okay, so the crucial thing to see is that the coefficient is the slope, right? The coefficient of x is always the slope. That is how fast y changes for every change of x. If x changes by 1 and you multiply x by f prime of 1, then y is going to change by f prime of 1. So that's what the slope is supposed to capture. So this is going to be the slope. And then finally also, like, we just have to check it passes through the point 1 comma f of 1. So if you plug in y is f of 1 and x is 1, you'll get 0 equals 0, which is a valid equation. So this is definitely the equation of the line. So now that we know that's the equation of the line, let's actually write it out. So we know what f prime of 1 is because we know f prime of x is equal to 2x plus 2. So what we can do is I'm just going to erase this here. So f prime of x is equal to 2x plus 2. So therefore we know that the equation of the line, so part B, is going to be the equation of the line is y minus f of 1. What is f of 1 going to be? It's 1 squared plus 2 plus 9. So it's going to be 12, right? So it's going to be y minus 12 is going to equal to f prime of 1. So f prime of x was going to be 2x plus 2. So f prime of 1 is going to be equal to 4. So we've got 4 times x minus 1. Okay, so therefore y is equal to 4x minus 4 plus 12, which is equal to 4x plus 8. Okay, so that is y equals to 4x plus 8. That is the equation of the tangent line at x equals to 1. okay? And you can check, that it really passes through the point at x equals to 1. If x is 1, then the y value is 12, and that's going to be consistent here, okay? So it is a tangent line, its slope is the derivative at 1. So now we've got to part C, which is the really cool part, which is find all the points that the tangent line passes through the origin, okay? So how is that going to work? So what I'm going to just show you first to understand what we're asking is a schematic picture, okay? So I'm going to erase all this off. This is going to be the equation of a parabola, okay? So x squared plus 2x plus 9, it's a quadratic. We don't actually have to draw the graph or anything. But I'm just going to show you the graph just to kind of give you a feeling for what the question is asking. We want to find out whenever the tangent line passes through the origin. So whatever the graph is, okay, so you have this graph. You can actually find it out like this. So, if you remember completing the square, you don't have to remember this, but you can complete the square. It's x plus 1 the whole squared plus 8. So you can sort of find the vertex of the parabola is going to be at minus 1, 8. So we've got minus 1, 8. And then you've got the vertex of the parabola, and then you've got something that looks like this. I'm not drawing it very much to scale, but something that looks like that. And you sort of see that as you vary the tangent lines, they're going to go through different points, right? This tangent line is going to go through here. So it's going to be a sweet spot where the tangent line is going to go through the origin, right? And we want to find out what is that sweet spot. And similarly, it's going to be, if you think about the other side of the graph, it's the same idea. As the parabola gets steeper and steeper, there's going to be a sweet spot which is going to go above the board, but it's going to be a sweet spot where the tangent line is going to go through 0. So, if you have that extra visualization, you don't need it, okay? The step-by-step process I'll show you will not need it, but it's always good for a depth of understanding to think about things visually and algebraically, okay? So what I'm going to do is I'm going to now work out how we're going to figure the answer to this question out, okay? So we need to solve for something that is going to now be a second variable, okay? So we want to find all a, so the tangent line at x equals a passes through the origin, okay? So the first question is, what is the tangent line at x equals a? This will be the equation of a line that will change as a changes. If you take the tangent line at different points, the line is going to change. So it's going to depend on a. But the line itself is going to be governed by an equation involving y and x, and the coefficients in that equation, the constants in that equation, are going to be in terms of a. So they are going to change as the point we're taking the tangent line, which is a, changes. Okay, so let's write that all out. So what we're going to do is, what is the tangent line? So this is part C. What is the tangent line at x equals to a? At x equals to a. So we know that, same process. I encourage you, if you're still getting used to tangent lines, just write it out. What is the slope first of all? The slope at x equals a is going to be f prime of a, okay? So it's a derivative at a, which is going to be 2a plus 2. We found that out in part A, coincidentally part A. 2a plus 2 is going to be the slope, okay? So that's the slope. What is the point on the graph, okay? So the point on the graph, so point slope form of the line, the point on the graph is going to be a comma f of a, and you can plug in, a comma f of a is going to be a comma, if you plug in x equals a in that equation of f of a, it's going to be a squared plus 2a plus 9. Okay, so that's going to be the point on the graph, and the slope is going to be 2a plus 2, so we want the equation of the line with that slope and passing through that point. Now, it's going to be an equation with y and x, okay? The a is going to be a different variable, but it's just because the point you're taking it at will change the tangent line, as I explained. So what we can do is we know the point slope form. So the point slope form is y minus f of a is going to equal to, so what is y minus f of a going to be? It's going to equal to f prime of a times x minus a. And so that's going to be y minus a squared plus 2a plus 9 is going to equal to f prime of a, which is 2a plus 2 times x minus a. So this is going to be the equation of the line that is tangent to the graph at x equals a. Okay, so it is an equation in terms of y and x. So whenever you fix a, you fix a value of a. So when a is 1, we'll get back the equation of part b, right? When a is something else, we'll get another equation. We want to figure out when that equation corresponds to a line that's going to pass through the origin. Okay, so as a changes, the line is going to change. So we're going to solve for a to figure out when this passes through the origin. Okay, we're going to solve for which tangent lines pass through the origin, and I'm going to do this on the left side of the board. And what we're going to do is we're going to ask ourselves this question, and I want you to drop a comment down below. What do you think we have to solve for here? How do we solve for a? What do you think the process is going to be? And if you're interested, you can also think about maybe other points as an exercise practice. Once you've understood this, is when does it pass through some other point in the plane, like 1, 3 or whatever. Okay, but first of all, to pass through the origin, what we're going to do, and if you've watched this far, thank you so much. It means so much to me. My goal is free accessible math education to support as many people as possible. I want to change lives, help people to learn and love math. Whatever goals you have, whether you want to pass an exam in college or high school, or you're just learning out of recreation, I want to support you. So by liking and subscribing and sharing with friends and family, classmates, other students, it really goes a long way to helping me achieve my vision of helping as many people as possible. So I'm going to now go into the problem. So to pass through the origin, we want 0, 0 to be a point on this line. So x and y have to be 0 and 0, and that should satisfy this equation. Okay, so what we're going to do is we're going to plug in x equals 0 and y equals 0. So plug in x equals 0 and y equals 0. And what we're going to get is we're going to get an equation that's just going to be involving a. So this is when the line is passing through the origin, which is 0, 0. So we're going to get 0 minus a squared plus 2a plus 9 is equal to 2a plus 2 times 0 minus a. Okay, so that's when, if this equation is satisfied, that means the line passes through the point 0, 0. X is 0, y is 0. Now we need to solve for a. And these are going to give us the tangent lines which are passing through the origin. So how do we solve for a? So we're going to get minus a squared minus 2a minus 9. Don't forget to distribute the minus signs in the parentheses. Anyone can make that mistake, so don't worry if you've made it, but just practice. So 2a plus 2 times minus a. So we're going to get 2a plus 2 times minus a. So that's going to equal to minus 2a squared minus 2a. So that's going to be minus a squared minus 2a minus 9. So now what I like to do is just, put everything on one side of the equation. You can cancel off terms you see on both sides. So minus 2a get cancelled. So we're going to get, minus 2a squared is going to go to the left-hand side. So therefore, we're going to get that a squared is going to equal to 9. Okay, minus 9 is going to go to the right-hand side. So therefore, a is going to equal to plus or minus 3. So those are the points of the graph where the tangent line passes through 0, and that corresponds with our geometric intuition. Visualize that before we did this, I showed you it's a parabola, and they're going to be two, one downward slope, one upward slope, which pass through the origin when there's a sweet spot, and that's corresponding to the points plus minus 3. So I hope you loved that video, on finding the tangent line. I hope you have a real mastery of finding the tangent line. I really love to support people to really benefit, love math, and master math, so you can do well. If your only goal is just to do well in calculus class in university, I'm here to support you. I want to support you whatever your goal is. I do hope that you'll enjoy the process and really get a mastery too in the process of watching this video. So thank you so much for watching. Drop a comment down below, if there are any topics related to this you'd like to see videos on. I'm always open to suggestions, recommend it to friends and family. I'd love to help as many people as possible to learn and love math. And I wish you all the best. I hope this video supported you, and wherever you are, I want you to be happy, successful, productive, enjoy math, and just be super confident. Okay, so just follow the steps, tangent lines made easy for you. So I'm super excited to see you in the next video. Please take care.